Good day everyone. Welcome to all. My name is Sachin Ahankari, working as Assistant Professor in Narasimha Reddy Engineering College, ECE Department. So today, in this session, I am going to give the introduction of integrated circuits and its classification. So before going into the topic, I will give the brief idea about the course contents of JNTU. The unit number 1 for R18 batch is integrated circuits. Unit 2 is op-amp and its applications. Unit 3 is active filters and the oscillators. Unit number 4 is timers and phase locked loops. Unit 5 is D2A converter and A to D converter and its types. The textbooks which are recommended by the JNTU are these three, that is Linear Integrated Circuits by D. Roy Choudhury, Op-Amps and Linear Integrated Circuits by Ramakant Gaikwad, and Digital Fundamentals by Floyd and Jain. Apart from that, I will recommend Coughlin and Driscoll as a textbook, and also the K.R. Botkar, Linear Integrated Circuits or Integrated Circuits by K.R. Botkar. So these are the textbooks which are going to cover your 100% of your syllabus. Now we will go into the topic. That is, what is integrated circuit and what are its types, what are the classification of integrated circuits, we will see. So integrated circuits is a miniaturized low cost electronic circuit consisting of active and passive components fabricated together on a substrate, and the active components are diodes and transistors while the passive components are resistors and capacitors. So here the silicon wafer is taken and it is treated as a substrate, and on that substrate all the active and passive components are fabricated on a single chip of silicon. That is your integrated circuits, and it is a miniaturized low cost electronic circuit. Miniaturized means the volume of the IC is less. It is going to occupy less area than the actual circuit is going to occupy. So why we are going to prefer the integrated circuits? So due to miniaturization and hence the increased equipment density. Due to miniaturization, there is a increased equipment density in the integrated circuits. Batch processing resulting in a cost reduction. So cost is also reduced when you are going to fabricate the integrated circuits in large scale. The cost of integrated circuit is also going to reduce due to the batch processing. So improved system reliability due to the elimination of soldered joint. So the system reliability is improved. Better functional performance, matched devices, increased operating speeds, and significant reduction in the power consumption. So that's why we are going for the integrated circuit. So these are the advantages you can call, or why we are using the integrated circuits. So these are the reasons to use the integrated circuits. So ICs are classified on the basis of their chip size. They are classified into 4 categories: small scale integration, medium scale integration, large scale integration, and very large scale integration. Apart from that, there is a ultra large scale integration and giant scale integration is also there, which is given into the book. So small scale integration, 3 to 30 gates per chip are manufactured in small scale integration, while in medium scale integration 30 to 300 gates per chip are manufactured, while in LSI 300 to 3000 gates per chip are manufactured, and in VLSI more than 3000 gates per chip are manufactured. So this is a classification based on the chip size. The ICs are also classified mainly as linear integrated circuits and digital integrated circuits. So linear integrated circuits, the relationship between the input and output of the circuit is linear, and here the relationship between input and output is not linear, or the circuit is either in on state or off state, and not in between the two. So it will be, the circuit output is always either it is on or it is off, it is not in between the on and off. So this is about your digital integrated circuits. So you can easily identify the linear integrated circuits. So for the operation or for the applications of the ICs, uh, if you are using external resistors and capacitors for the integrated circuits, then that integrated circuits are linear integrated circuits. So op amps, if I'm going to for the application such as integrator, if I am interested to fabricate the integrator, then I have to attach the resistors and capacitors outside the IC. So that's why the IC 741 is a linear IC. So here in the digital IC, you are not going to attach any resistor or capacitor externally to the IC, and just input and power supply input and output are there in the digital IC. No external resistors or capacitors are attached for the applications or for the proper operation of the digital IC. So if you go for the next types, so the types of integrated circuits, the integrated circuits may be classified as either monolithic or hybrid. Most of the linear ICs are produced by the monolithic process, in that all the transistors and passive elements are fabricated on a single piece of semiconductor material. The semiconductor material is generally a silicon. That's why it is called as a monolith. So monolithic is a Greek word, and the meaning of monolithic is one stone. It is one stone, single stone or one stone. In monolithic ICs, all the components are formed simultaneously by the diffusion process. Then the metallization process is used in the interconnecting these components to form the desired circuit. The monolithic process makes low cost mass production of ICs possible. Also, monolithic ICs exhibit good thermal stability because of the all the components are integrated on the same chip very close to each other. However, the large values of resistances and capacitances that are required in some linear circuits cannot be formed using monolithic process. Moreover, there is no method available to fabricate the transformer or to form the large values of inductors in the integrated circuit forms. However, if the components are required in a given application, external discrete components can be used with the IC, with the monolithic IC. So, the another type of integrated circuit is hybrid IC. In hybrid IC, passive components such as resistors and capacitors and the interconnection between them are formed on a insulating substrate. The substrate is used as a chassis for the integrated circuits. The active components such as diodes and transistors as well as monolithic integrated circuits are then connected to form a complete circuit. So for this reason, low volume production methods are best suited for hybrid IC technology. Hybrid ICs are further classified into two categories, that is thin film IC and thick film IC. When suitable material is evaporated on a substrate in forming resistor, capacitor and interconnection, then a thin film hybrid IC is obtained. On the other hand, in thick film IC, resistors, capacitors and interconnections are etched on a substrate by the silk screening, not by the evaporation like in thin film IC. So thin film IC and thick film IC, hybrid ICs are classified into thin film ICs and thick film ICs. So this is about your another classification of IC, and what are the limitations of monolithic IC? The power rating, low power rating, due to the low power rating, you are not using the monolithic ICs for higher power applications. So for higher power applications, you are not going to use the monolithic ICs for due to low power rating, and cannot be used for the higher power applications as it has a low power. You cannot use it for more than 1 watt. The isolation between the components within the integrated circuit is poor in the monolithic IC. Components such as inductor cannot be fabricated, and the passive values, passive component within the ICs will have small value, and external connection is required from the IC pins to obtain high value. And flexible circuit is not possible here in the monolithic IC. So these are the limitations of your monolithic IC. So we will see how the IC is going to look inside the IC. There are, as you see here, there are terminal pins, and there are connecting wires. If I am going to remove the case of IC, you will find that there is a silicon chip, and from the silicon chip the connections are there, and from the these connections are given to the terminal pins here. So on this silicon chip or substrate, you are going to fabricate active devices or passive devices more than up to 1 million, up to 1 million devices you can fabricate in the silicon chip here. So this is about your integrated circuits, inside view of integrated circuit. So what are the applications of integrated circuits? The applications are, they are used in communication, control system as well as instrumentation system. They are also used in the computers and in many of the electronic circuits also. So the advantages of integrated circuits, they are having the small size, low cost, light weight or less weight, low power supply voltages. Since we are using low supply voltages, low power consumption is available with the help of low power supply. Highly reliable and matched devices, as well as the speed is fast. So these are the few advantages of the IC. So we will see the chip complexity, chip size and complexity in the next lecture. Thank you.